everyone, and welcome to this week's engineer interview. We're joined by Reuben Brambleby from Anglia Ruskin University. Now, my name is Scott and I work at Primary Engineer. Before we start, I just want to say thank you for signing up to this year's competition. It's our 10th birthday this year, so thank you for celebrating it with us. For those of you who don't know, this is the Leaders Award competition. We asked the question, if you were an engineer, what would you do? Pupils from the ages of 3 to 19 anywhere in the UK can join, and every single person who takes part receives a graded certificate from a real-life engineer, just like the ones we interview. We've already started receiving entries from across the UK, so remember once you've finished yours to send them to us at Primary Engineer HQ. Now, as part of these interviews, we're going to be speaking to engineers who work on loads of different projects, all of them showing the wonderful, interesting and exciting things that happen when you work in engineering. Although we host these interviews live, we do record them so you can catch them at a later date. Now, our speaker is going to start with a 10-minute presentation all about the built environment and how he teaches the engineers of the future. And then we're going to open up to the audience for questions. If you would like to ask a question, simply type it in the chat function using Teams. We unfortunately can't receive audio from the audience, so if you do have a question, simply type it in. But for now, I'm going to hand over to our wonderful special guest, Reuben.
Okay, thanks very much, Scott. Yeah, so thank you all for joining us today. So as Scott says, I'm Reuben Brambleby and I'm a lecturer in civil engineering at Anglia Ruskin University. So I'm going to talk to you briefly today about what is civil engineering and what do civil engineers do. Okay, so what is civil engineering then? So civil engineers are involved in designing and constructing pretty much all of the human-made, all of the built environment that you see around you. So I guess most of you are in a school at the moment, so that school building, civil engineers would have been involved in designing that school building and constructing the school building. You will have travelled from home to school by some means, maybe on foot, maybe on a bike, in a car, on a train. All of these things use infrastructure, so that's roads and walkways, bridges. All of these things are designed and constructed by civil engineers. So really, civil engineers are involved in all of the things that make our lives kind of comfortable and allow us to carry out our lives as we are used to doing it. So if we look at some of these images here, so we can see we've got some offshore wind turbines in the top left here. So civil engineers were involved in designing and constructing those. Here we've got an image of a train travelling on a bridge. The bridge is going over a watercourse. So the bridge, the watercourse, and the whole of that train track. Civil engineers would have been involved in designing and constructing that. Now, civil engineers aren't really involved in designing the train. That would be a different branch of engineering, probably mechanical engineering. But in terms of the bridge and the track itself, that civil engineers are involved in that. And then what else we're seeing? So here this image represents coastal engineering or marine engineering. That's part of civil engineering. Here we've got a building structure. Again, structural engineering is part of civil engineering. Here we've got a water treatment works. So you turned your tap on this morning so you could clean your teeth or make a cup of tea or have a shower. So that water was purified at a water treatment works, and water treatment works are part of civil engineering. And here we've got a landfill site and maybe some geotechnical work. So as we can see, civil engineering is a very broad subject, covers many of the things that we see and use every day. Okay, so that's how broad civil engineering is. And if we think about almost all engineering tasks, we can think of them as having kind of two separate phases in a way. We have a design phase and we have a construction or a manufacturing phase. And to some extent within civil engineering, you can think of those as almost being two different career paths in the future when you're thinking about getting a job in the future. And if you think about going into civil engineering, you might be thinking about these two things as two different career paths within civil engineering. And so in the design phase, what's happening is you have to, as an engineer, we have to identify a problem, we have to understand what the problem is, or we have to identify a need, something that someone wants. For example, the school that you're in, someone decided, okay, we need a new school building, and engineers and architects would have come along and been involved in that decision-making process. And now engineers will be required to come up with a number of different solutions, a range of different solutions to the problem, or a range of different answers to the need. And during that design phase, the engineers are comparing those different design options. They're thinking about which one is the most effective, which one is the most economical, which one is going to be the fastest to construct, which one's going to last the longest. All of these decisions have to be made. And it's a civil engineer who will be involved in many of those, or involved in many of those decisions and many of those comparisons. And during that design phase, of course, we'll be working, the image here represents working in a design team. We'll be collaborating with many other people, many other engineers, many other people from other professions, architects, local authorities, all sorts of different types of people. So there's lots of team working, lots of collaboration is required in civil engineering. We also need to, as civil engineers, we need to be generating calculations. We need to, predict how something is going to behave, and often we're using calculations for that. We need to be generating drawings to communicate our ideas, generating reports. So all of these different aspects are part of civil engineering and skills that we need to have as civil engineers. And then so that's kind of the design phase. Now, if we think about the construction phase, of course, design phase tends to come first, and we generate the designs, generate the drawings and so on. And then those go over to the constructors or the contractors. And contractors will have civil engineers on their teams as well. And the civil engineers will be involved in, for example, this image down here, we've got an image of people taking measurements on site. Of course, when you construct a building, you have to make sure it's in the right place. You have to make sure the walls are vertical. You have to make sure everything is in the appropriate place, the rooms are the right size and so on. And all of that means taking measurements and converting a drawing into the physical thing on site. Down here, we've got people constructing. So there's some concrete being poured here. So this is a basement for a residential building that I worked on a little while ago. And so these folks are, pouring that concrete and constructing the building on site. And these are students on campus here last year. So some of our civil engineering students actually working on a construction project out on campus. So, and of course, there's lots of interaction between the design phase and the construction phase. And civil engineers who work on the design phase must have experience of working in construction, and vice versa. People who work in the construction phase need to have some understanding of the design phase. And in fact, of course, that we can swap between one side of the diagram and the other side of the diagram. Okay, so that's some of the things that civil engineers do. And here's a diagram which tries to talk about some of the things, some of that wide range of skill sets that civil engineers need to have available to themselves. So problem solving, whether you're on site or whether you're in the design office, of course, problem solving is key. Finding solutions to problems and coming up with a range of different solutions to problems and choosing the best one. I've mentioned calculations already, both on site and in the design office. We have to do calculations to predict how something is going to behave, or to take measurements and make sure we've got things in the right place. Many different aspects of different calculations that we need to carry out. On this idea of teamwork, of course, I've mentioned about teamwork in the design office, working with a wide range of different people in the design team, and of course on site, working with contractors, working with neighbours. In many aspects, when you're working on site, you're working in a team, communicating and finding effective ways of working. Haven't really mentioned too much about materials yet. So I mentioned we saw that picture of the concrete being poured, but of course there are many different materials used in construction. So concrete, steel, timber, glass, other metals, earth for geotechnics, water. All of these, can be considered as different materials that are used in civil engineering, and we have to understand how those materials behave. We have to understand how to predict how those materials are going to behave. And so on. And then, of course, how we construct with those materials when we're on site. So I've got another thing here, environment. So environment has many different aspects. Of course, it's a very broad subject. So on the one hand, we need to understand how the environment is influencing our projects. So if we're thinking about a building, how does the wind affect our building? How does rain affect our building? That side of the environment. But then there's also the impact that our constructions or our projects have on the environment. And maybe we could think of that as being encapsulated by sustainability. We need to be, any new construction that we do is taking resources, is causing resource depletion. Any new construction is creating new greenhouse gases. I'm sure you're all aware of greenhouse gases and how important they are to us. So in any construction, we need to be aware of all of these both negative and positive impacts of our construction, and we need to try and mitigate or lessen the impacts on sustainability. We need to make sure our projects are sustainable. So I think I've covered everything. I've got these two, this etc. here and etc. here, just to identify. This is only just one selection. These are the things that came off the top of my head while I was putting the slides together. Of course, there are many other aspects within civil engineering that we need to be able to take care of. Okay, so that's civil engineering in a very broad sense. But what about me then? So I teach civil engineering, but in fact, I'm a structural engineer. I'm a chartered structural engineer, and structural engineering is a subset of civil engineering. As we've seen already, there are many different subsets of civil engineering, and structural engineering is one of those. And I just thought it would be useful. So for me, most of the projects I've worked on have been building structures, and so we can see on the images here, these are some images of just a few of the projects I've worked on, and you can see that they're all, one way or another, they're all kind of building structures. And I wanted to highlight the fact that, civil engineering gives you an opportunity to work across the world almost. So you can see I've had an opportunity to travel to quite a few different countries, quite a few different cities across the world, because of working on, different projects in those cities. So, of course, most of my projects have been in the UK. And in fact, many of my projects have actually been in London. So, this project here is a residential project, so a block of flats in London. This is refurbishment of Birmingham New Street Station, up in the Midlands. And here's a student accommodation in Oxford. But further afield, I've also worked on a project in Naples, in Italy, so a high-speed train station. Worked on a project in Shanghai, the UK pavilion at the Shanghai Expo, and also a project in Azerbaijan. Now, I didn't actually get to travel to Azerbaijan, but I travelled to Turkey to work with engineers who are working on the project. So it's been really interesting. I worked as a structural engineer for like 13 years or so in industry, and you can see I've worked on some very interesting projects using many different materials. And I've had the opportunity to travel quite a bit. And now I'm not in industry anymore, and I'm now actually teaching in civil engineering. And so now I'm sort of trying to help the next generation of civil engineers, civil and structural engineers, find their careers in civil engineering. Okay, so that's my bit done. So hopefully there are some questions, and I'd be interested to hear any questions that you have.
Remember, if you do have a question, just simply type them in using the chat box in Teams. But I've got the first question, Reuben. What do you love about your job?
Oh, that's interesting. Quite a few things, to be honest. One thing is, sort of being creative. Maybe people would not really think of engineering as being a creative discipline, but in fact, it is quite creative. We have to, find many different solutions to problems. And so, using my knowledge of materials and my understanding of, the behavior of materials and structural behavior, and kind of using those skills in a creative manner in collaboration and working with other people. I find it, obviously really interesting working with a wide range of different people. So I guess probably those are the top two things: using my skills in a creative way and, working with other people, I guess.
Yeah, and it seems that you've got to work on some really cool projects as well. We've got some questions coming through here on the chat now. So this question comes from Isaac in year 5 at St Aidan's. How long have you been doing your job for?
Okay, so the job I'm doing at the moment, I think this is my 6th year. So probably to you guys that seems like ages, but to me that doesn't seem very long. So I've been a lecturer for 6 years, and then then prior to that I was a student actually studying for a PhD. So I did a PhD in engineering, and then my main bulk of my time has been as a practicing structural engineer, and that was for about 13 years.
We've got a question here from Miss Boys, and Miss Boys asks, what made you want to be an engineer?
That's a good question. I don't have a really very good answer to that. Yeah, so I started out actually in electronics, and I think I started in electronics just because for some of it that kind of interested me. I used to have an interest in sort of computing, and electronics seemed well connected. And I think it's just the way my mind works. My mind works in a kind of an engineering way, I suppose, about solving problems and wanting to learn about how things work, how things behave, and then applying that knowledge. So I suppose, it's a bit of a vague answer, but I guess that's really what it is. It's about wanting to understand how things work and then being in a position to put that knowledge into practice, I suppose.
It does sound... No, it does, and it sounds quite exciting, especially considering you get to be so creative with it. Because that's what you were talking about earlier. In fact, when it comes to sort of coming up with these solutions to problems, this question's from Charlotte Verity, and Charlotte asks, how hard is it to come up with good engineering solutions?
Yeah, well, that's sometimes extremely difficult. It can be very, very difficult, but sometimes not so difficult. So yeah, it depends. I mean, sometimes you will have worked on a project where you've had to solve a similar problem, or a problem which you can find you can use a similar solution to. Yeah, but sometimes it is very difficult to find answers to the solutions to the problems, and sometimes we have to go. I mean, for example, I'm in the hydraulics lab at the moment. So for example, on the Shanghai Pavilion project, it was an extremely complex project, and we didn't have good answers to the problem straight away, and so we had to try out many different things. And some of that experimentation was actually physically trying things out, building a model and seeing how that model behaved. For example, we used bamboo. We were trying out bamboo at one stage. We tried acrylic. We tried aluminium. So you can see sometimes it's quite easy to find a solution, and sometimes it's very difficult, and therefore you have to use many different resources to find solutions to your problem, whether that's calculations or physical modeling, or even going and speaking to other experts. If you recognize that you're not an expert in a specific area, maybe you go and find other people that have more expertise in the area. So sometimes easy, sometimes very difficult.
And I suppose that's all part of working on so many different projects. Some are going to be, oh, hang on, I've done something like this before. I know what to do. And then, oh, no one's ever done this before. How are we going to figure it out?
Exactly right. Yeah.
So we've got another question from Charlotte Verity in the Primary 7 class at Hillwood Primary. What subjects do you have to take at school to be a civil engineer?
Okay, so that's a very good question. So to be honest, things are becoming more flexible. We're recognizing in civil engineering that we want a wide range of different people to become engineers in general, and also and to become civil engineers. And so traditionally, maybe like 10 or 15 years ago, I think the standard answer would be mathematics for one, and then probably physics would be another obvious one, and then other subjects. But I think we're recognizing now that that's not necessarily true. I mean, you do need to have some mathematics ability. I mean, as I said, I've mentioned calculations quite a few times. So some mathematics, but you don't have to be a mathematician. You don't have to be an absolute mathematics expert. I mean, I certainly wouldn't consider myself to be, super good at mathematics by any stretch. But nonetheless, I'm a chartered structural engineer. I did a PhD in civil engineering. So, I'm not certainly not a mathematics expert, but I've managed to, be an engineer, let's say. So maths would be one, and then after that, I think we are becoming more and more flexible. So, physics would be an obvious one, and I find physics very interesting. I did physics at school, but I think we're becoming more and more flexible. So yeah, there isn't really a very set subject. If you have an opportunity to do, for example, design and technology at school, or even engineering at school, these are really useful subjects, because in those subjects you are finding a range of solutions to a problem, and you're thinking about comparing different solutions, comparing different answers. So yeah, so there's quite a wide range of subjects which are really relevant.
And it sounds like if you've got an interest in it as well, and this idea of problem solving, then that's such a driver as well.
Exactly right. Yeah, that's right.
So we've got a question a bit more about yourself in civil engineering. This comes from Daniela in year 6 at St Aidan's. What makes your job important?
So so my job at the moment, I guess, is important because we need civil engineers. In this country, we don't really have enough civil engineers. So training young people to become civil engineers and is quite important, I think, because as I say, all of our buildings, all of our roads, all of our energy infrastructure, our water infrastructure, all of these things need civil engineers to develop new ones, to build new ones, and even to maintain the existing infrastructure. So we need civil engineers. So that's why my job at the moment is important. And then when I was a structural engineer, I suppose maybe you would say important, because a structural engineer's job is to make sure, okay, if we're talking about building structures, it's to make sure the building doesn't fall down.
Yeah.
I mean, I'm sure you've seen on the news there was a very large earthquake in Turkey recently. And so of course sometimes we find that structures aren't able to deal with the forces that are exerted on them, but it's the structural engineer's role to try and make sure that they can withstand the forces that are exerted on them. Okay, earthquakes are a special case, of course. We can't necessarily make everything earthquake proof, but even in the UK we have to make sure that our buildings are safe and durable and stand up.
Yeah, and as you said, buildings make sense. We see them, but it's almost, I think you said earlier, it's the built world is designed and constructed by civil engineers. So it's not just buildings, it's also bridges, and you even said like water treatment factories. In fact, this is a question that was asked earlier as well. You also showed wind turbines. So one of the questions we had is, I've lost it. It was how important are engineers when it comes to tackling climate change?
It's a really good question. So super important, I would say, really critical, because engineers are involved in creating new stuff. So I was involved in designing and creating new buildings. Engineers are involved in designing creating all of that built infrastructure, and all of that new stuff creates greenhouse gases during its construction and so on. All of that stuff is depleting the world's resources, and part of engineering is to make sure that we can achieve what we want to achieve with the minimum effect on the environment. That is becoming more and more important. So so engineers are really critical in terms of what was the actual question in terms of?
It was just and when it comes to tackling climate change. So like
Tackling
you said, then
climate
even
change.
new buildings that you need for safety, for people to live in a safe and a safe home, but it needs to be built in a certain way.
Yeah, exactly. That's right. And so that's one aspect. To make sure that the new stuff that we create has the smallest impact on climate change as possible. But the other thing is, climate change, the climate emergency, is causing changes to the environment. It goes without saying. And so our new structures, our new infrastructure needs to be resilient. It needs to recognise that the environment is changing. Maybe that means higher wind speeds, more rainfall, higher temperatures, lower temperatures, all of these different changes that are coming about due to the climate emergency. Our new structures need to be able to be resilient and be able to deal with those changes as well. So on the one hand, we want to try and minimize the impacts we're having, but then on the other hand, we need to recognize that changes are happening and we need to have resilient designs due to that.
One thing you said as well was that in the UK we need more civil engineers, and we've had a few questions about sort of becoming one. So one question is from year 6 at St Aidan's. How long does it take to train as an engineer? And there's also been a couple of questions about whether or not it's a well-paid career.
Okay, so how long does it take? Okay, so where to start? So if you think about an engineering degree, I mean, an engineering degree, so a civil engineering degree is either 3 years at university or 4 years at university. So that means, okay, so then you've got your degree, but that's there's still more training that happens after that. So for example, as I say, I'm a chartered structural engineer, and so I did a 3-year undergraduate degree, and then I went to work in a structural engineering practice, and then I think it was another 4 or 5 years. I think I was working before I took my chartership exam and passed that to become chartered. So, strictly speaking, I mean, I would like to say that you're an engineer once you become chartered. Now that's not a clear-cut thing in the UK, unfortunately. But if we think about, you're an engineer once you become chartered, then you might be thinking about a 3 or 4 year undergraduate degree, and then maybe another 3 or 4 years of practice, experience in practice to become chartered. And then you're asking about pay. Okay, so pay, it depends on what scale you're talking. Pay is reasonable. It is quite good. I mean, it is reasonably well paid. Of course, there are many more well paid jobs, but engineering is quite well paid. Yeah.
Well, I hope that's answered some questions out there about those thinking to go to study engineering. We have got time for a few more questions, so anybody out there has some, please type them in. This question was one that was sent in to us. Now, you said that the lived world is designed by civil engineers and constructed by them, but do they take any inspiration from the natural world?
Yeah, that's a good question. So, I mean, yes is the short answer. Yes, definitely we do. So, for example, if we think about thinking about sustainability and the environment, it's becoming more and more common to use timber as a construction material for large building projects. Of course, timber's been used, since we started building things, we've been using timber, but for quite a long time, large building projects would tend not to use timber. They tend to use steel and concrete. But now we are moving more towards using timber for large building structures, and so we have to understand how that. Of course, timber is a natural material. We have to understand how the timber behaves, and we have to think about why trees have evolved to be as they are, and we kind of can use that as an inspiration for some of our structures. And what else to say? I mean, certainly if we think about, like water courses and even coastal engineering and marine engineering, then we do have to understand how nature behaves, and maybe it's not exactly taking inspiration, but developing an understanding of how nature behaves, so that our new constructions have as small an impact on nature as possible, so nature can do its thing. And another aspect as well. I mean, I'm working on a research project at the moment, which we're calling Nature Plus or Nature Positive Living Lab. And nature positive solutions are solutions where we allow nature to do its job, so in a positive way. So maybe we might think about drainage, the way rainfall is dealt with in terms of drainage, and we want to think about utilising nature and allowing nature to do its job in the most positive way, in the most beneficial way for us. So, I mean, the short answer is yes. Now, not always to the greatest extent, but we do take inspiration from nature, definitely.
Brilliant. We've got 2 more questions just to round us off for this afternoon. The first one is from the Hillwood primary class. Do civil engineers use VR?
Okay, yeah, we do, yes. So, so VR, virtual reality, I guess is what you mean. And so when we out on site, I mean, this is relatively new. So, I mean, for example, I've never used VR on site personally, but it is happening, and it allows people to, for example, if we think about a building probably even the building that you're in, there are many components to the building. There's the structural aspects, so that, you know, columns and beams and floors and so on, and then there are other aspects such as lighting, heating, getting water around the building, and all of those different aspects. They're all kind of different aspects of engineering, but they have to interact in some way. So I'm in a building which has air conditioning in it, and so that means there is pipe work carrying the air for the air conditioning, and we have to make sure that pipe work that's carrying the air isn't interfered or doesn't interfere with the structure. And so sometimes VR is used for that purpose. So you can actually, maybe you've got the building is constructed, the structure is in place, and you would use VR to then visualize where is the ductwork going to go, where are the ceilings going to go, and so on and so forth. So the short answer is yes, we do use VR in civil engineering, particularly when it comes to on-site, and also, in fact, maybe if we're trying to present a design to our client, sometimes we might use VR for that as well.
That's quite clever. So we've got a question here from year 6 at St Aidan's, and it's also in reference to what you were mentioning earlier about the terrible disaster we've seen in Turkey and Syria. As we're thinking today about the terrible loss of life in the earthquake, can engineers design buildings that are earthquake proof? Okay,
so to say earthquake proof is maybe a bit too far, but certainly earthquake resilient. So with any engineering, in essence, what you're doing is you're finding a balance between the likelihood of something happening. So let's say the likelihood of an earthquake exceeding a magnitude of 7, for example, and the cost of designing for that likelihood. And so, of course, as things become less and less likely, then sorry, I should express that differently. As the severity of a problem gets more and more, then it becomes more and more expensive to make a building resilient to that. So, you know, to make a building resilient to an earthquake greater than magnitude 8, for example, is much more expensive than making a building resilient to an earthquake of magnitude 7. And so, of course, we have to find a balance between, do we really want to spend all that money for something which may never happen, or which may only happen every 100 years? You know, that's a choice we have to make. So to say earthquake proof is, we probably wouldn't say we make them earthquake proof, but we can make them earthquake resilient. And certainly, for example, I saw a tweet the other day, earlier today, from a colleague, a guy who used to be a colleague of mine, and he was saying that, you know, the level of destruction that happened in Turkey shouldn't be happening. We do know how to make buildings resilient enough to resist, you know, those sorts of earthquakes. So yeah, it's not a straightforward answer, and unfortunately things in engineering aren't straightforward answers. It's seldom a yes or a no. There's always some caveat. So not earthquake proof, but definitely earthquake resilient.
Yeah, and they can definitely help. So we've just got one final question in here. This one comes from Charlie Burke at St Aidan's. What was your favourite project to work on?
Yes, what was my favourite project to work on?
We saw some pretty amazing ones from around the world.
Yeah, I don't know. That's quite well, that's really tricky. I mean, yeah, so different ones for different reasons. I mean, yeah, I suppose. Well, it's very difficult for me to pick a really specific one to say one is definitely my favourite. But to be honest, most of those ones that we saw on the images were you know, really good. And maybe we would say that, you know, the Shanghai Pavilion. I mean, in a way, I don't want to say that because it was a temporary structure, and so therefore, you know, it doesn't sit very well with me because it's a lot of work for a temporary structure. But it was super interesting, and working with really interesting people, and you know, really unique design. So yeah, that's certainly one of them, certainly in the top 5, let's say.
Brilliant. Well, look at the time. I just want to bring this session to an end. Thank you very much for that, Reuben, and thank you to everyone out there. Hopefully you've learned something today and you've all been inspired to be the engineers of the future, because now it is your turn to come up with your own engineering ideas. Remember, and send them to us once you're finished so we can get our certificates sent out, and then we'll hopefully see you all in person at our public exhibitions at the end of the school year. Now, don't forget, this interview will be uploaded to YouTube, so if you want to share it with your other teachers or if you want to rewatch it in full, you can subscribe to our channel and find it there. But for now, I want to say thank you to you all. A massive thank you to Reuben for speaking to us today. And remember, if you were an engineer, what would you do?